Students, do you like money? Well, I know I do. And money can be a very useful tool for acquiring good things or helping out charities. So it's good that we use math to help us understand money. And money, which is really helpful, follows an exponential growth pattern when you invest it properly. Now, to determine exponential growth, y equals you'll have a number here which is going to represent your initial amount. And this could be money if we're talking about money, or we could talk about animals that are breeding at an exponential rate. We could talk about a lot of different things. But since it's initial, we'll just put an I for the initial amount. 1 plus, right here, this represents your growth rate. So if the exponential growth rate is 50%, well, 50% is 0.5, so we would put a 0.5 here. I'm going to put R for rate right here. And then finally, this is an exponential growth lesson, so we need an exponent. This exponent is t, and t stands for time periods. Time periods. And it's important to distinguish that it's not just time, it's time periods. And we'll see in this example right here. Investments historically have doubled every 9 years. That's true. If you invest something properly in a good mix of stocks and bonds, then typically you'll see your investments double every 9 years. That's great news. Everybody would want to double their money. If you start with a $500 investment, your exponential growth equation would then be y equals 500 times 2 to the xth power. How much money would you have after 36 years? Let's analyze this problem as it relates to our exponential growth equation. Our initial amount was $500. So that made sense that we put y equals 500 there. But then there's a 2. Well, this says 1 plus the rate. Well, if your investments are doubling, that means that they're growing at a 100% rate. So this was like 1 plus 1. And then, of course, we have our t for time periods. So parentheses, well, that comes first in order of operations. So we have y equals 500. 1 plus 1 is 2, and that's where the 2 came from. And now we have to raise this 2 to a certain power. Now looking at the problem, it's actually very tempting to write to the 36th power. But remember, t does not stand for time, it stands for time periods. Investments don't double every year. If they did, well, we'd all be very rich people. Investments double every 9 years. So that concept of your money doubling happens every 9 years. So after 36 years, how many time periods have there been? How many times has your money doubled? Well, if it takes 9 years for it to double one time, it would take 18 years to double it 2 times, 27 years to double it 3 times, and 36 years to double yet again for the fourth time. So in order to calculate your time period, you take the total number of years and then you divide that by how long it takes for your investment to double. So 36 divided by 9 is 4. So this is going to be 2 to the fourth power. So let's calculate how much money we would have after 36 years. Well, 2 to the fourth power, 2 times 2 times 2 times 2 is 16. And the reason that we do 2 to the fourth power instead of 2 times 500 is because exponents come before multiplication in order of operations. So now we have y equals 500 times 2 to the fourth power, which we found to be 16. So now we have 16 times 500. Well, that seems like a pretty difficult multiplication problem, but let's just do 16 times 5 and then add the 2 zeros at the end. That'd be easier. So 16 times 5 is 90. 16 times 5. 16 times 5. Carry the 3. 5 times 1 plus 3 is 80. So you shouldn't always take my word for it. Check the answer yourself. So y equals 16 times 5 is 80 with 2 zeros. So 80 with 2 zeros, or $8,000. So if you invested $500 today, and you invested it in a pretty good mix of stocks and bonds, after 36 years, you could have $8,000. That's pretty awesome. That's called the power of compounding. And you want to take advantage of that as you get older. Make sure to invest your money so you have money later on for the important things in life. For exponential growth, remember, you put your initial amount times 1 plus the growth rate, and then you raise that to the number of time periods. Thank you very much, and have a great day.